eventually, you can also type it directly. There is no problem typing directly. Um, you can import it. We might look in another occasion, how to import a Excel spreadsheet. So here we have the data. So every time we have to analyze data, the first thing we do is what? What we do? We want to look at the data, so we are going to plot. All right,
yeah.
we're going to plot the data. To plot the data, pay attention. You see the menu bar, and there's a send to. Send to plotting. And the plotting, I choose XY plot. All right? Click. And now I have to choose what should I plot. Okay, this is different from Excel, right? It's a different, so I choose time, we're going to be my X, the hexametazone, we're going to be my Y, and the treatment is called group. All right, because I'm going to group per treatment. And when I've done, I'm going to click on the red wheel. You see here the red wheel, click. And here it is, all right? See how nice is already here. So this immediately I can tell there is a difference, all right? Because the itraconazole is the yellow line, the placebo is the purple one, and you can tell I gave the same dose to the same subject, so something is there. But this is why, we have to quantify these something, what happened, okay? So what we're going to do, I go now again to the worksheet. Click on the worksheet. And now I'm going to send to, and I choose Windows 5 Classic Modeling. And then it gives me a various possibility like dissolution, indirect model. These are in alphabetical order, all right? I'm going to choose PK model. PK stands for pharmacokinetics, all right? PK model. And here I have a selection of possible models. And now you can see they have, they are identified by this first is select. So the one I click is going to select. The number, so it's sort of the ID of the model, 1, 2, 3. This is included, is sort of a Windows ID. We have the type of input. Input could be IV bolus, IV infusion, first order. So, in a sense, makes IV bolus, IV infusion, oral. All right? You should read this first order as oral. Compartment. Compartment refers to the type of distribution. Could be 1, 2, and exceptionally we can have 3. It does the 3 only for the IV infusion and the IV bolus. We can choose if we want to parameterize. What does it mean now, parameterize? What are the parameters, the primary parameters I'm going to calculate? Is going to be the micro constant or the macro constant? What is the difference? Let's say if I have C is equal A, we did it last week, all right? Minus alpha T plus B E minus beta T. So A, B, alpha, and beta, these are macro constants.
Macro, yeah.
All right? Instead, if I'm going to write C, and then now I don't remember, I think it was like alpha minus K to 1, and then I don't remember, this was what? Alpha minus beta, I'm not sure it's correct, all right? Minus alpha, and so on, all right? So if you write in this form, this will be the micro constant, all right? And then we will see, okay, there are a lot of, this is a selection, of course, is given only for the 2-compartment model, because when we have a single compartment, one compartment, there is no macro constant or micro constant, all right?
Mhm.
So how do I choose? So again, my first guess is I'm gonna look at the plot. We said that in a normal paper, Cartesian paper, is difficult to tell if it's one compartment or two compartment. So I'm gonna go and plot on a logarithm. And so you can see it's pretty much a straight line. So this is what we're gonna do next week. Next week we're gonna see how to choose between one compartment, two compartments, three compartments. Today we just wanna have a free ride, an easy ride, all right? We just say, well, you know, it looks very much a single, a straight line, so it's very much a one compartment. So I go back to the MyPK, and I choose IV bolus. So I choose model 1 for my data. Because it's an IV bolus, it's one compartment, is, let's see, there is more. And the elimination is first order. Of course, it's an IV bolus, there is no lag time. So I want to tell the computer that it's going to choose time is my independent variable, dexamethasone is the concentration, and the treatment is my salt. This is the main worksheet. Now I have to introduce the dose. Now you see what I do. I am under the tag of the setup. I did the main, and now I go the dosing. For the dosing, I choose, I click here, use internal worksheet, and I use treatment as my group. So the dose is only a single dose. With the treatment was with itraconazole. The dose was administered at time 0, and the dose administered of dexamethasone was 3.8. You know, you remember the salt factor I did. If I convert 5 milligram of dexamethasone sodium phosphate in dexamethasone, they become 3.8. Okay? And now here, the same as in Excel, I have this nice little square I can fill down, all right? Because again, we use really Phoenix for 1 to few data sets. But the power of this program, you can work with 100 or dozen of data sets. It's enormous. So the initial estimate now I have to choose. Oh, one thing that maybe tonight was not so clear is that when you have nonlinear a minimization process, you have to start with what is called the initial guesses or initial estimate. All right, and here with nonlin or Phoenix is calculating the initial estimate for you. But most of the time, when you have your own model, that is one of the most difficult things. We're going to talk about that later. How will do the initial estimate? It's going to do the slope. We're going to take 2 points, the same as we were doing last semester, just to take the intercept. But the computer is going to do by itself. So, and the units, this is good. Oh, you see, there is no units. So what I did, because when I did the dose, I forgot to put the unit of the dose, that is milligram. I have also the possibility to normalize the dose. This is not, could be normalized per kilogram, per body mass, and so on, all right? Body surface, I say none. And I have the possibility to choose the weight. Now, I start with no weight, so just to make, to see what happened. So I think I have everything right now, and then I just run it. Again, I'm gonna press the wheel. You see the red wheel, click. And that's it. You see, if you were to do with Excel to find the slope, the intercept, and all. And now, just a blink of an eye and everything is here. So what is this? This is a long, big. We're gonna talk more, about this. But we see this is all the output. Look at that. the condition number, the correlation metric, the diagnostic, the dosing, you know, how many things. So, we're gonna talk later more extensively. For tonight, we're just gonna be happy, you know, we see what is this, VNK10. Because the model we use, you know, was, we said, you know, it was simple like that, was the C was equal to V over V e to the minus K10T, all right? So that, so the only parameter we have is V and K10, all right? We're gonna look, as I said, you know, the CV percentage, and there is very nice, small, all right? 1.6 is good, all right? We have well, this is the confidence interval. The confidence interval. Oh yeah, because this is in milliliter. Oh, one thing I didn't do, you know, is very nice. Winolin can do. Let's go back to setup. Who, you know, it's very not nice to have a volume of distribution of 70,000 milliliter. All right. So we just go back to setup. We go to unit.